Hello everyone, welcome back to my learning session for Apache Pig. In previous video, we discussed about introduction to Apache Pig. In this video, we will discuss about how Pig comes and correlate with Hadoop. So let's start for that. First of all, we have to understand that how Pig is coming on Hadoop. So Pig runs on Hadoop. It makes use of the Hadoop distributed file system, that is HDFS, and Hadoop's resource management system, that is YARN, into the system. HDFS is a distributed file system that stores files across all the nodes in a Hadoop cluster. It handles breaking the files into large blocks and distributing them across different machines, including making multiple copies of each block so that if any one machine fails, no data is lost. By default, Pig reads input data file from HDFS, uses HDFS to store intermediate data between MapReduce jobs and write its output to HDFS. It means Pig is taking all data from HDFS, doing all the operation, and again it's putting it back to the HDFS. And after that, all the operation is going in the normal way. In the other hand, YARN stands for yet another resource negotiator. That is the resource management layer of Hadoop 2. It consists of a per cluster resource manager, node manager, and an API to write distributed application that runs on the cluster. Well, in Hadoop 1, the only available engine for executing operation was MapReduce. In Hadoop 2, the field was expanded and other applications such as Tez and Spark start to cooperate and use it in the Hadoop system. Let's discuss something about MapReduce. So MapReduce is a simple but powerful parallel data processing paradigm. Every job in MapReduce consists of three main phases. The first is map, the second is shuffle, and the third is reduce. In the map phase, the application has an opportunity to operate on each record in the input separately. So what happening, as I told you that Tez is another alternative for MapReduce. So Tez is an alternative to MapReduce for processing data in Hadoop. It executes a collection of connected tasks and moves the data between those tasks. Tez is more general and flexible than MapReduce. It provides better performance and low latency, which will speed up most MapReduce applications. It has been adopted by high-level developers tools such as Pig. So let's now go through and jump to directly understand that how an example in MapReduce is happening and how the same example is working in Pig and how it is differ from each other. So consider a simple example. MapReduce is an application that counts the number of times each word appears in a given text. This is the simple program of MapReduce. In this example, the map phase will read each line in the text one at a time. It will then split out each word into separate string. For each word, it will output the word and a 1 to indicate it has seen the word one time. After that, what happening? It will shuffle each word as a key, hashing the record and reduce it. After that, in the last phase, the reducer phase will then sum up the number of lines each word was seen and write it together into the reduce phase. So let's see here that my example is Mary had a little lamb. Its fleece was white as snow, and everywhere that Mary went, the lamb was sure to go. So what happening? The SDF is going to divide this big file into some small chunks. So in the first map, the first line is coming as a Mary had a little lamb. In the second map, the second line is coming like its fleece was white as snow. In the third map, the third line is going on as everywhere that Mary went and the lamb was sure to go and come into the fourth map. So what happening? It will start to break it into the per word by word. So you are able to see here that map is come as one, Hadoop had is come as one, a one, that is one, lamb one, and it follow the same steps. After that, shuffling is going on here, okay, and it will come into the reducer phase. And what happening into the reducer phase? It will reduce and count each word at one condition, like had comes one, comes one, little comes one, lab comes two times, Mary comes two times, watch comes two times, like that. But if we see the same example in Pig Latin, so what happening when Pig is running, MapReduce has becomes the execution engine. It compiles the Pig Latin scripts that user writes into a series of one or more MapReduce job that it then executes. So what happening inside the Pig Latin? It will first load input from file. So the command is input is equal to load Mary, as a line. We are loading as a line. After that, we are going to tokenize it and split the line into words. So words is equal to for each input generate flatten, tokenize the line as words. Don't need to worry about that. I will discuss this codes in more details once we are going to do in the practical way. After that, once the line will be divided into the different words, we will group the words as per the similarities. So group word is equal to group word by word. After that, we'll count and dump it into HDFS. So count word is equal to for each group word generate group, count all the words, and after that dump count word into that. So we understood that how MapReduce job, which is taking at approximately 70 to 80 lines, but Pig Latin is doing into the 4 lines of simple operations, right? So we have to understand that how Pig differs from MapReduce. So Pig team is to make Pig Latin, and we have to understand that how Pig differ from MapReduce. So one question is always coming into the mind, like why is Pig necessary? In the other hand, we have MapReduce, and does MapReduce really not provide enough? So this type of question is coming in the mind. So we have to discuss that how MapReduce is completely different, means is going to be different, and Apache Pig is going to be recomposited. Okay, so Pig offers users several advantages over using MapReduce directly. Pig Latin provides all of the standard data processing operations such as join, filter, group by, order by union, etc. Such as MapReduce provides the group by operation directly, and it provides the order by operation indirectly through the way implementing the grouping. Another condition furnishes some complex operations, non-trivial implementation of this standard data in a quick manner. Okay, but in the case of MapReduce, the data processing inside the map and reduce phase is opaque to the system. This means that MapReduce has no opportunity to optimize or check the user's code. We are understanding that map reduce is like little bit of tough due to Java programming, low level programming, but in the case of Apache Pig it is quite fast. So if some team is working on some big programming in the map reduce, they will take the days and days and days, but in the case of Apache Pig it will take like little of the hours time. Okay, so according to the complex nature, map reduce is so complex compared to Apache Pig, and there's no way to optimize code in MapReduce, but we can optimize code in Pig. So today we understood very deeply about how Pig come into Hadoop system and what is the role is going on there. In the next video, we'll discuss about data types in Pig. If you think that this video is really informative for you, please give a like and don't forget to subscribe my channel, as well as please share this channel with others. Thanks.